in a whole wide, wide world. Say now I'm from a city in the Midwest, best city in a whole wide, wide.
Okay, good afternoon. Thanks for being here today. We're presenting now the problem of the hammer and the chain. I forgot to mention, my name is Cesar. Here we go. So, we have an athlete, right? And he's whirling a 7.75 hammer, and it's tied to the end of 1.5 chain in a horizontal circle. The hammer moves at a rate of 0.40 revs per second. What is the acceleration of the hammer? Let's begin. Okay then, we're back at the problem again, and now I'm just going to show you simple steps of how to solve the problem. Okay then, so now we're going to begin with what we know right here. We know that he has a hammer that's 7.75 kilograms in mass. Next, we know that with his arm, it's 1.4 meters plus the chain. Lastly, we know that 0.41 is the revolutions per second that he's spinning it in a horizontal circle. First, we begin with what we need to know, simple equations. Centripetal accelerations equal v squared over r, which also equals the radius times omega squared over r. Okay, so let's begin. Right now, we have 0.4 revs per second. We will need to convert that into radians per second. Simple math right here. Just multiply by 2 pi 0.41 should convert to rads per second, and that'll give us 2.51956 rads per second. Okay then, right now we're going to use the equation where we have r omega squared over r equals the centripetal acceleration. Okay, we distribute the exponent r squared omega squared over r. R's cancel out. We have r omega squared right here, and we're going to use, simply just insert the radius, have it right here, 1.4 meters, multiply it by the radians that we just got from earlier, which is 2.51956 rads per second. And remember that this portion right here is still squared, the omega, and our final result shall be 8.88744 meters per second squared. This is your centripetal acceleration. Okay, so right now we just did the hammer and the chain. In the first part of the problem, we're looking for the centripetal acceleration. Right now, we're going to find the tension in the chain. Okay, so now we're going to take it another step, and we're going to find the tension in the chain. First, we need to begin with F equals ma's. Basic rule of physics right here, force equals mass times acceleration. We're gonna convert that, not really convert it, but I mean just change it a little bit. Our tension is gonna be our force, of course. We're gonna have a mass, and we're gonna need an acceleration. We're gonna use the centripetal acceleration that we found from the previous problem, okay? So we just plug everything in. Right now we have 7.75 kilograms right here. It's for our mass of our hammer. And we're gonna use our 8.88744 meters per second squared. Okay, and with the help of simple algebra right here, we're going to get an answer of 68.8776 newtons. And that answer is right. Okay then guys, I'm going to thank you all for coming and having to listen into this, circular motion. We're going to have some more installments of this, and you guys have a good night. Thank you.